So picking up where we left off, this is on the middle of page 3. It says to convert between different substances in the same chemical equation, you must always convert to moles first. So moles is going to basically be your stopping point in between different substances. So I like to use what I call the mole map to convert between these different things. So if we are starting in grams, which often we are, I'll use 2 different colors for this one. So starting with red, we'll say if you are in substance 1, that will be your given substance. You can start in grams, and to get between grams and moles, the conversion factor that we use is called molar mass. And molar mass is always how many moles?
1.
Perfect. Always 1 mole. And the number of grams comes from our periodic table. So I'm going to zoom this in just so I can write it really small up above this. The number of grams is from PT, for periodic table. So we will go between grams and moles all the time. You can only use molar mass when you are using a specific substance and going between grams and moles of that specific substance. Then we have our balanced chemical equation. I'll make this gray. This is what we have been practicing with, or this is what we used yesterday, where we can go from moles of one thing into moles of something else. So I'll use a different color, blue, from moles to moles. And the conversion factor that we use there is called the mole ratio. This comes from your coefficients. So you don't always have 1 mole there. It can sometimes be different numbers. It just depends on what the coefficients are in your balanced chemical equation. So sometimes your coefficients are 1, which means sometimes you'll use a 1 in your mole ratio, but oftentimes they are not. So this is where you can get different numbers of moles. And so the arrows are showing you can go both ways. You can go from one substance into another, and so on. And then once you are in your other substance, you can go back and forth into grams of that second substance. So I'm going to say substance 2, which is what you are looking for. I'll say unknown. What this means is this is what the question is actually asking us about. So again, between grams and moles of my other substance, I need to use molar mass. This is always 1 mole. And the number of grams of that second substance still comes from the periodic table. But notice that there is nothing connecting the grams of one substance to the grams of another substance. There is no way to get from grams of substance 1 into grams of substance 2. You have to go to moles to grams. So we use this like a roadmap, just like we did in semester 1. We're going to use this to help us when we get lost. And then this mole map, just like the one that we drew on the board, can continue on the other side, and that's kind of what we're going to add on to it today. So moles can go into 3 different things using Avogadro's number. So I think we have more space. I'm going to give us a lot of space on this one. So using Avogadro's number, 1 mole equals 6.02 times 10 to the 23rd things. And just like we talked about last time, those things are generally going to be atoms, molecules, or formula units. I don't. Thank you. So to convert between moles and atoms, the conversion factor is that 1 mole equals 6.02 times 10 to the 23rd atoms. 1 mole equals 6.02 times 10 to the 23rd molecules, or 1 mole equals 6.02 times 10 to the 23rd formula units. And so we're just going to mirror that exact same thing on the bottom for substance 2. So we can go all over the place, but the only thing that connects these two lines between the two substances is moles. So that is what I'm talking about in the statement up above. So I'm going to highlight that so that it maybe stands out to us a little bit more. Oops. Why does it keep doing that? Oh well. So to convert between different substances in the same chemical equation, you must always convert to moles first. So I'm going to continue this one on. So I'm going to say 1 mole equals 6.02 times 10 to the 23rd things. And then those things are the same things that we just listed up above in red. It can be atoms, or it can be molecules, or it can be formula units. So all of the stuff I wrote in red is talking about one specific substance, and all of the stuff I talked about in blue is talking about a different substance. So if you need to convert between one substance and another, and the way that you'll know you need to convert is because the question will give you some kind of information, grams or moles or particles of one thing, and then it will ask you for grams or moles or particles of something different. So let's try example number 1. It says determine the mass of NaCl produced when 1.25 moles of chlorine gas reacts with sodium. So I'm just going to switch my pen color. So what we are looking for in this is the mass of NaCl produced. So my final answer, when I'm all done with it, is going to be something grams of NaCl. Since that is what it says, determine the mass of NaCl, and the unit that we use for mass is grams. So grams of NaCl will be my final unit. If you are able to show me that you understand just that information, you have already earned yourself 1 point there. And then our given information in this question is 1.25 moles of chlorine gas.
Wilson?
Yes.
Yeah, Courtney.
Yes.
Thank you.
Thank you.
Yes, we didn't hear you.
Some office. Do you know where it would be? I would maybe go to AP office, but if they don't know what you're talking about, go to the front office. I don't know who that was on there. I couldn't tell. Okay, so we'll start with our given information of 1.25 moles of chlorine gas. Remember last time we talked about our diatomic elements. We have our Brinkelhoff elements. So since chlorine is diatomic, I know that the formula for chlorine is going to be Cl2 and not just Cl. And then the other way that I can tell that it's Cl2 is because in my equation, that's what I have. There is no just Cl by itself. It's Cl2, and there's a little g there to tell you that it is a gas in this case. So then we draw your line. You don't necessarily know how long it needs to be yet, but give yourself plenty of space. And before I get too far, I need to remember to start with a balanced chemical equation. So this equation right now, I have 2 chlorines on my reactant side and only 1 chlorine on my product side, so I'm going to give it a coefficient of 2 right here. 2 times 1 sodium would change that to 2 sodiums on my product side, so I need 2 sodiums on my reactant side as well. And then I've got 2 of everything. So your coefficients are 2, 1, and 2. Remember that if you didn't need to change the coefficient, it would be a 1. So then if I have moles of Cl2 to start, I would disco down those units to bring moles of Cl2 to the bottom. And from Cl2, so if we're here, my given substance, so I'm going to use our mole map to help us out here. My given substance is chlorine. I have information on it. So if I locate where I'm starting on the map, I'm not in grams. I'm currently in moles of my given substance. So I'm here. Moles of my given. I'm looking for information on a different substance. So that's what tells me that I need to go to this blue line somehow, right? So if I'm starting in moles of chlorine, my next step is that I need to use the mole ratio with the coefficients from my balanced chemical equation to get into moles of my other substance. So I'm going to put moles of NaCl on top of moles of Cl2. The conversion factor between those two things is the mole ratio. So that's why I put that on the mole map. The mole ratio comes from my coefficients. So next to Cl2, I had a coefficient of 1. Oops. And then next to NaCl, I have a coefficient of 2. Since moles of NaCl is not what my question is asking me for, I need to keep going. So I'm going to do moles of NaCl on the bottom. So now I'm here, I'm on my blue line, and the question is asking me for mass, which is grams, and so I can go to grams of my same substance, so grams of NaCl. Between moles and grams, even though the equation has a coefficient of 2 in front of NaCl, and we use that 2 to say 2 moles of NaCl, we have already taken that coefficient into account. I'm not going to take it into account a second time. This is why we put on our mole map that molar mass between grams and moles is always 1 mole. So I put a 1 here, and the number of grams is what comes from my periodic table. So I don't use that coefficient in this mole right here because this is grams to moles, so we use that differently. So then I need to look at my periodic table to determine the molar mass of NaCl. So here I have chlorine. Oops. Sometimes it works and sometimes it doesn't like to. Whatever. All right, chlorine. So I would use 35.45, and then for sodium, I would use 22.990. So plug this into your calculator. We add those two together, and in my equation, or in my formula, I don't have any extra subscripts. So there is nothing to multiply it by. So 22.990 plus 35.45, and I'll give you a minute to calculate that. All right, when I press enter, what do I get?
58.44.
Perfect. So 58.44 is the molar mass of sodium chloride, which tells me that for every 1 mole of sodium chloride, I have 58.44 grams. Then I have this entire long setup, and there are multiple ways that we can type this in. So my preferred method is to just type each thing, multiply by everything on top, divide by everything on bottom. In this case, there are no numbers on the bottom that are going to change the value of our answer, because if I multiply anything times 1, or if I divide anything by 1, it's going to remain the same, so this doesn't change my value. So as far as units, my moles of chlorine will cancel, my moles of NaCl will cancel, and I'm left with just grams of chlorine. And then all I need to do to solve this is type in 1.25 times 2 times 58.44. So this times this times this. Again, if there were numbers on the bottom, I would need to divide by each of those, but there is nothing on the bottom that would change my answer. And if you're not sure when to determine if it's going to change your answer or not, there's no harm in typing it in. It's just an extra step that several of you already understand that you don't need to do. So what did we calculate? Perfect. 146.1 is my final answer. I already set up my units that way, so you can put that right on the line, or you can get rid of this and say grams of NaCl. I like to remind you guys during each of these how you're going to be graded on it so that there is no confusion later on. So remember that you would get a point for your number and a point for your unit, a point for your number, a point for your unit, number, unit, number, unit, and then this one, I would give you 2 points for that number since you had to calculate it and that took more effort than pulling your coefficients, and then unit, and then number, unit. So this kind of question would be worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. So 13 points is no joke on these questions. Let's do the next one. It says determine the mass of the sodium needed to complete the same reaction. So again, just like we did in one of our previous questions, if it says same reaction, that means that it has the same given information. So if I'm using my same given, the given information that I had up here was 1.25 moles of chlorine gas, so I'm going to use that again, 1.25 moles of Cl2. And now, instead of looking for the mass of sodium chloride, I'm just looking for the mass of sodium. So this is going to be something grams of sodium. My equation is kind of lost in here. Just want to make sure that we can still see it. So it's still the same coefficients, 2, 1, 2. My moles of chlorine would come down to the bottom. And moles of what I'm looking for, sodium, would go to the top. So again, if we find ourselves on this mole map, I'm in my given substance. Given substance meaning I have information about that substance. Moles of chlorine was what was given to me. So that is what tells me that I'm starting up here. It was given in moles, so I'm already here. If I want to go to a different substance, the only way to get to that other substance is by using the mole ratio and the coefficients to get to moles of that other substance. So moles of Na, and the numbers that I put here are my coefficients. So for every 2 moles of sodium, how many moles of NaCl did I have? Or sorry, not NaCl, moles of chlorine. Sorry, I was looking at the wrong thing. Moles of Cl2 would be just 1 from that same chemical equation. And then back at your mole map, if you're here, so we converted from moles of one thing into moles of another thing. From here, where do we want to go next? To grams of that same substance now. So I need to use molar mass, which is always 1 mole, and the number of grams comes from the periodic table. So I would bring moles of sodium, Na, down to the bottom, and grams of sodium, the same substance, up to the top. And molar mass is always 1 mole. And then the number of grams of sodium just comes directly from our periodic table. So again, that is this, Na, 22.990. I don't need to multiply it by anything because in my equation, it's just sodium. It doesn't have any extra subscripts. It's not bonded to anything. And the fact that there are 2 of them, I have already taken into account using my mole ratio. So then to solve this one, I would type into my calculator 1.25 times 22.990. So then what do we get? Ooh, I think what I said out loud was not the right thing. I didn't multiply mine by 2. That's the right answer. You got it. So what you should have typed in your calculator, if you listened to what I said the wrong thing, I'm pretty sure. 1.25 times 2 times 22.990. What I typed in was just 1.25 times 22.990, but I skipped this one. Don't know why. Yes, the right answer is 57.475. If you only have 3 decimal places, I would go ahead and write all 3 of them, but if you have just like an irrational number that just keeps on going, a super long decimal, cutting it off at 2 or 3 decimal places is usually fine. Rounding to a whole number, unless that's the exact answer that the calculator gives you, is usually way too much rounding. All right, let's do the next 2. So these 2 problems have 2 different equations that we're using. So starting with the first one, I have NH4NO3 decomposing to make N2O and H2O. So first, let's go ahead and balance this. I'm going to draw my R and P chart down here, but then I'll erase it so it just gets out of the way. I have nitrogen, hydrogen, and oxygen. On my reactant side, there are 2 nitrogen atoms, 4 hydrogen atoms, and 3 oxygen atoms. On my product side, I have 2 nitrogen atoms, 2 hydrogen atoms, and 2 oxygen atoms. So, any ideas for the first steps to balance this? Perfect. Okay, a 2 in front of H2O, 2 times 2 hydrogens would give me 4. 2 times 1 oxygen would give me 2 oxygens from H2O, plus I need to add to that the 1 oxygen from N2O, so I have a total of 3. And then we're balanced. We have 2 and 2, 4 and 4, and then 3 and 3. So just to get all the extra stuff out of my way, I'm going to erase it. So your coefficients would just be 1, 1, 2. So question 3 says, determine the mass of H2O produced. So right away, I can start by saying blank grams of H2O. I knew I would be in grams because it asks for the mass, and that's how we measure mass. And what our starting information is 25.0 grams of ammonium nitrate, which is that formula right there. So I'm starting with 25.0 grams of NH4NO3. So if we identify ourselves on this mole map, I'm going to use a different color to sort of outline where we're starting and where we're trying to go. So if I use a highlighter here. In question number 3, oops. The highlighter likes to work on different things. Starting question number 3, we are starting in grams of NH4NO3. So that means that NH4NO3 is my given substance, and I'm starting in grams of it. So I am starting right here. The question is asking me for grams of H2O, which is a different substance. It is not the same substance that I'm talking about. So I'm trying to go from grams of NH4NO3 into grams of H2O. So what you can do with your mole map is route yourself from one step to the next. I can't go just from grams to grams. So how am I going to get there? From grams of NH4NO3, where do I need to go first? Moles of what? NH4NO3. Good. Then from moles of NH4NO3, where can I go? Then I go into moles of H2O. Good. And then the conversion factors are all listed here for you. Then from moles of NH4NO3, I go to grams, or sorry, from moles of H2O, I go to grams of H2O. So our steps are going to go grams to moles to moles to grams. Oops. Every time I try to scroll on this. Let me see if I can use this. Better. Okay. So I have grams of NH4NO3. I need to get rid of that unit, so I bring it down. grams of NH4NO3. I bring that down to the bottom so that it cancels out, and then I refer to my mole map to tell me where I'm going next. I already mapped this out for myself. I'm starting here. The only place I can go from here is into moles of that same substance. So what I'm going to put on top is moles of NH4NO3. I don't want to end in moles of NH4NO3, so I'm going to keep going. So I bring that down to the bottom so that it cancels out, moles of NH4NO3. From moles of NH4NO3, I already mapped out that I'm going to go to moles of my second substance, my unknown substance. That's the one the question is asking about. So in this case, what is that substance? H2O. So I'm going to go to moles of H2O. And then from moles of H2O, I need to go to grams of what? H2O. So again, I bring down my moles of H2O so that it cancels. And I put grams of H2O at the top. So the way that we've set this up is that my grams of NH4NO3 will cancel with that. My moles of NH4NO3 will cancel with that. My moles of H2O will cancel with that, and the unit that we're left with is grams of H2O, which is perfect because that's what we're looking for. And then we can use what we wrote for ourselves on the mole map to help us figure out the conversion factors for each of these things. So between grams and moles of NH4NO3, we're in our given substance. Grams and moles, we need to use molar mass, where the number of grams comes from our periodic table and the number of moles is always 1 mole. So I can go ahead and put a 1 next to moles, and the number of grams, I need to calculate that. So I'm going to leave that for just a second. We'll come back to that one. And then between moles of H2O and moles of NH4NO3. Moles to moles, my conversion factor is what we call the mole ratio using the coefficients. And the coefficients are talking about our balanced chemical equation. So I'm looking at the equation that we balanced for this question to start. I can go ahead and fill that in since those are given to me. H2O has a coefficient of 2, and NH4NO3 has a coefficient of 1. And then between grams of H2O and moles of H2O, we're here in our second substance. Moles to grams, we're still using molar mass, which is always 1 mole, and the number of grams comes from the periodic table. So if we go back to calculating molar mass, I'm going to calculate the molar mass of 2 different things while looking at the periodic table. One is NH4NO3, and the other is H2O. So for NH4NO3, what you need to do when calculating your molar mass is show me each of the elements that are in that compound. And then you'll list how many of each there are. So for nitrogen, how many nitrogens are in this compound? 2. So I'm going to use parentheses and say 2 times, and then what I multiply this by is the molar mass as it's listed on the periodic table. So nitrogen, 1 nitrogen has a molar mass of 14.007. So when I have 2 of them, that's where I multiply it by 2. So 14.007. And then for hydrogens, how many are there? 4. So I do 4 times the molar mass of hydrogen, which is 1.008. And then for oxygen, I have 3 of them. So 3 times the molar mass of oxygen. Oops, this one.
15.99.
Good. So 15.999. And then there are multiple ways that you can do this. If you use parentheses like this, you can just type this entire thing in one long string into your calculator and end up with the right answer. If you forget to put parentheses on any of the spots that you need them, then it will mess up your answer. So if you feel more comfortable calculating the product each time and then adding them together at the end, that is also fine. So I would type into my calculator If you have not typed this in yet, you can go ahead and clear whatever you have. Start with me. I'm going to tell you every single button to push. So clear it, open parentheses, 2 times 14.007. Close your parentheses, and then we'll hit plus and open new parentheses, 4 times 1.008. Close your parentheses, plus open parentheses, 3 times 15.999, and then close your parentheses. If you do it that way, you should have gotten what answer?
I got
80.043. Do we agree? Okay, just real quick to show you that you can do it the other way too, I'm going to calculate each of these. I'll put them in a different color so that we don't get confused, but it will end up with the exact same answer. So I can do 2 times 14.007, and that gave me 28.014. And then I do 4 times 1.008, and that gave me 4.032. And then I can do 3 times 15.999, and that would give me 47.997. If I add all 3 of these together, it should give me the same answer as that, but just to make sure, 28.014 plus 4.032 plus 47.997. And it does. So, 80.043. Exact same answer both times. Just go based on whatever you feel more comfortable using. I've found that a lot of students are pretty inconsistent with their parentheses, and then they get really frustrated because when you type it into your calculator, if you forget to open or close parentheses in some place, then you get a syntax error in the calculator and you have to start all over again. So just be very careful as you're going through it to make sure that you're actually pressing all the right buttons. So what this number tells us is the molar mass of NH4NO3. So I'm going to take that number, and that is what goes right here. So this, my pen, 80.043 will get plugged in right there because that is the number of grams of ammonium nitrate per mole of ammonium nitrate. And then we need to follow that exact same process to calculate the molar mass of H2O. So slide over just a little bit. So for H2O, I'm going to take hydrogen and oxygen. I have 2 hydrogen atoms times the molar mass of hydrogen, which is 1.008, plus I have 1 oxygen atom times 15.999. So this gives you 2.016. This gives you 15.999. Again, you can just add those 2 together, or you can type all of this with the parentheses and everything into your calculator. And either way, you end up with 18.015. The units for molar mass, remember from last time, are grams per mole. It's the same thing on the other side as well. I just didn't use units on there. Grams per mole, because the units are given in our setup. So this is how many grams that are in 1 mole, grams per mole, grams per mole. So in our equation, when we have this set up in the T-chart this way, it makes sense. It's 18.015 grams per mole, per 1 mole. And then when we plug all of this into our calculators, we'll multiply by everything on top and then divide by everything on bottom. So I'm going to type 25 times 2 times 18.015. And then usually when I get to the end of the top, I hit enter, and then I'll hit divided by 80.043, and then hit enter again. And the answer that I got from this is 11.2533. Is that what you got?
Yes, sir.
Perfect. So I'll just cut that off at 11.25. Make sure that you round correctly. If it needs to round up or down, just do whatever it would require. And then a question like this one took a whole lot of effort, so this is why I give you double points when you need to calculate molar mass. You would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 points for a question like that. So even if you don't remember how to do every single step of this, showing me as much as you can do is extremely beneficial. So I'm going to scroll up and erase the marks that I did to show where we were going in that question. That way we can kind of track our path again for the next one. So number 4 says, calculate the number of grams of NH3 produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. What this word excess means is just that you will not run out of it. So not going to run out. That means you don't use this towards your calculations. So first step, just like always, balance your chemical equation. I have nitrogen and hydrogen, 2 atoms of nitrogen, 2 atoms of hydrogen. On my product side, I have 1 nitrogen and 3 hydrogens. Since I have a 2 and a 3, oftentimes we want to make this into a 6, so I'm going to multiply by 2 on my product side. 2 times 1 nitrogen gives me 2, and 2 times 3 hydrogens gives me 6. So then I go back to my reactant side to make them match, and a coefficient of 3 in front of hydrogen would give me 6 hydrogen atoms as well. So my 2 and 2 are balanced, my 6 and 6 are balanced, so that makes this coefficient in front of nitrogen what? 1. Perfect. So the 1 just tells me that I didn't need to use an extra coefficient to change that. And then I'm just going to erase my work so that it stays out of the way. This is why I showed you guys to put your R&P charts like on a separate piece of paper or put it off to the side. That way you have the space to take up whatever you need for your actual question. All right, so number 4 says calculate the number of grams of NH3 produced by this reaction. So my given information is 5.40 grams of hydrogen. I'm going to go ahead and plug that right in. 5.40 grams of hydrogen. Since hydrogen is diatomic, it is H2, and we also can tell that from the reaction. I'm going to just go ahead and make my line longer now. And then at the very end, I will know that I am done with this when my unit ends in what? Perfect. So grams NH3 is what we are looking for. So I'm going to just put a question mark under that one since that's what we're looking for. So again, I have 2 different substances. I got information on hydrogen, but I'm looking for information on NH3. So I'm going back to my mole map. If you don't know where to start, your mole map is always a good place. So I'm starting in my given information always. You will always start in given, but it's just a matter of what you are given. So sometimes we'll start in moles of our given like we did up in this example 1, but here we're starting in grams. So grams of my given information is where we're starting. From grams, the only place we can go is into what? Where can you go from grams?
Moles.
Into moles. Oh, I started to just drift a little bit. Moles of what? Same substance or different substance? Same substance. So from grams of one substance, you can go into moles of only that same substance. Then from moles of that substance, if we want to get to a different substance, am I going to keep going this way, or am I going to go down?
Down.
Down. Good. I need to keep erasing these. Okay, so grams to moles of my second substance, and then what we're looking for in this case is grams of my second substance again. So it is following the exact same path that we did in the question above this. So I'm going to start out. I have grams of hydrogen. I'm going to bring grams of hydrogen to the bottom so that it cancels. And then I'm going to pause here to walk around and help you all as you set this one up, following the exact same path that we did previously. So you can refer to question number 3 to help you out with the steps, or you can look at the mole map that we just outlined our path on. But I want you to get practice setting this up. And the way that this is, if you cross through molar mass twice, that means you're going to have to calculate the molar mass of 2 different substances. So keep that in mind. So pausing here to allow practice time. All right, picking up where we left off to practice, I brought grams of H2 down to the bottom, but why did I do that? So that it cancels out. So every time you're doing this...
Pardon the interruption. Do you have Taylor Britton?
I do, thank you.
Can you send her to the conference room on A Hall?
Yes, ma'am.
Thank you.
Thanks. So grams and grams will cancel. And then to figure out where you're going, I think that what I was seeing is students not understanding how to use this map and why we're actually going for it. So again, my advice is to practice with it and use it as the resource that it is, because if you are given this mole map on a test or a quiz or anything like that, it gives you most of the answers. It's just about knowing how to use them. So every single time, no matter what, you are going to be starting in your given substance, which means you are somewhere on this top line. So the first thing to figure out is where specifically are you on this top line. So in this case, we are starting in grams of our given substance because I have grams of H2. That is what was given to me. So you don't get to pick. That's just based on how the question is. Our goal is to get the number of grams of NH3. So I have grams of NH3 down here at the bottom as my unit on my final answer. So that's where I'm trying to go, grams of a different substance. But I'm not able to go directly from grams of my starting substance into grams of my other one, so I have to take this path. What I want you all to do is on your notes, so that you see these as like the destinations that I'm trying to get them to be, is box in the actual units of everything. So from grams to moles, that is way too thick. I'm going to make it smaller. But I want you to box in what these things are. So grams will be a destination. Moles is a destination. Each of these would be a separate destination when we get to them. This moles is a destination, and this grams is a destination. So when I say, can you get from what to what, I'm talking about going from grams to moles, or from moles to moles, or from moles to grams, or whatever it is. So each of these you should recognize as something different as a unit that you would plug in on your periodic table, or not on your T-chart table, sorry. So from grams, that's what we're starting in, of our given substance. We are always going to be starting in a substance, and even if you get it mixed up, oh, I don't know if I'm in substance 1 or substance 2, it doesn't matter because they're identical lines. It's like two different trains that you have to get, the only stop between the two trains is your mole ratio. So between grams of one substance, or from grams of one substance, there is only ever one place that you can go, which is to where? Moles of that same substance. So from grams of anything, you can go into moles of that same thing. There is nowhere else that you can go from grams. So if you are in grams, then no matter what, your next step is going to be moles of that same thing. Oops, gotta change my pen. So moles of H2 comes up here. Just like when we set up our first units, this one is going to come down to the bottom so that it cancels out because we are not looking to end in moles of H2. Once I get moles of H2 down here, okay, now this is my current location. From moles, you can either go back to grams, or you can keep moving forward on your line of your same substance to get to any of these things, or you can change substances. You can cross over to the other train line. In this case, since our question is asking us about a different substance, that's why I want to go down to moles of my second substance. So I'm going to go to moles of NH3 in this case, since that's what the question is asking. And then I would bring down moles of NH3 so that it cancels. And from moles of NH3, I can go other different ways. I can go to atoms or molecules or formula units, but again, that's not what the question is asking. This question is specifically asking for grams of NH3, which is grams of my second substance, so I'm going to go from moles to grams. So between moles and grams of anything, looking at this or this, the conversion factor between moles and grams is called molar mass. And I had you right that molar mass is always 1 mole. But several of you were really confused on what to do with that information. This means that in your T-chart, next to where it says moles, the number that you put here is going to be 1. If you are going from grams to moles, the number is 1 for moles. Same thing here. The number will be 1 for grams to moles. Then from moles to moles, that's where we're crossing over from one substance to another. The only thing that relates one substance to another substance is the coefficient in their balanced chemical equation. So I will use the coefficients here for my mole ratio. So H2 has a coefficient of 3 in this equation, and NH3 has a coefficient of 2. And then I would calculate my grams of H2 and my grams of NH3. My grams of H2 comes from the periodic table. Hydrogen has a molar mass of 1.008, so I multiply that by 2, which gives me 2.016. And then NH3, I would have to separate them out. I would take nitrogen and hydrogen. I have 14.007 as the molar mass of nitrogen, and I would have 3 times the molar mass of hydrogen, 1.008. So what does this give us? I know you calculated it. 17.031. Okay, so I'd plug that in, 17.031. Then moles of H2 would cancel out, moles of NH3 would cancel out, and I'm left with my only unit. So the top right will always be your ending unit because it's the only thing that you didn't set up to cancel. And then plug this into your calculator. I think that this might be the first one that we've done that has 2 numbers on the bottom that you have to type in to actually calculate this. So even if you've gotten all the other ones correct, make sure that you type this in with us as we type it. So I'm going to type 5.40, sorry, 5.40 times 2. Again, I can skip the 1 from moles of H2 because it doesn't change my answer at all. Then I can type times 17.031. Then I hit enter. And then you hit divided by 2.016. And then after you type in 2.016, you're going to hit divide again by 3. And then your final answer, rounded to 2 decimal places, is what? I think I heard it. 30.
It's 30.41.
Perfect. If you did not get this, but you have everything set up correctly, that means that there's an issue with how you're typing it into your calculator. So if you need help typing it in, please come see me and I will help you.